All right, welcome to the last video of week 4, just a review of factoring. It's going to feel like really this is the same stuff we've been doing because you really have been reviewing all throughout this week, because this has been one big review if you really think about it. So 6 problems and then that's it. You're home free for this week. So let's get started. All right, so if you look a couple things. Number 1, decide what type of factoring. So remember your choices. You have GCF, perfect square, A equals 1, A is greater than 1. And then number 2, is it factor or solve? Right, so solving, you're going to see equals 0. And that's really it. So the first thing I would do, just looking at the whole worksheet, number 1, you're going to have to split and solve. Number 3, you're going to have to split and solve. Number 6, you're going to have to split and solve. Okay, the other 3, you're just going to end with that, those 2 binomials or whatever they might look like. Looking at the types, just really quick off the bat, 1 and 2 are those 2 terms. So number 1, you have 12 and 9. 9 is a perfect square, but 12 is not, so 9 is going to be a GCF. Number 2, you have 1 and 9, which are both perfect square numbers, so this is going to be a perfect square. Number 3, you have 3 numbers, but you have 49 and 1. Most likely this will be a perfect square. If not, it's going to be a grouping, but with a number like 49, you hope that it's a perfect square. Number 4, we're looking at this number. Number 5, we're looking at this number. And number 6, we're looking at this number. So since there's nothing there in number 4, that's an A equals 1. Number 5, there's nothing there, so it's an A equals 1. And number 6, there is some, I highlighted in the wrong spot, number 6. Number 6, we're actually looking at what's attached to the x squared, not just the space in front of it. So that is going to be an A is greater than 1. All right, so let's get started and try some of these. So if we are talking about the GCF number 1, we're going to pull out a number, and then we're going to end up with a binomial. Okay, so we're definitely going to be able to pull out an x because they both have an x in it. And when we're talking about a 9 and a 12, we're definitely going to be able to pull out a 3. Can't pull out a 6, can't pull out a 9, can't pull out a 12. So 3x times what gets me back to 12? Love you, bud. Sorry, my son. 3x times what gets me back to 12x squared? It's going to be a 4x. 3x times what is going to get me 9x? And that's going to be a 3, because we already have the x there. And we're going to need a negative there. Now that's going to be equal to 0, because again, we still have that 0. If I get rid of that, so I can split and solve this. Split this, so I get 3x equals 0. I get 4x minus 3 equals 0. I'm going to divide both of these by 3. I'm going to get x equals 0 here, because I can have $0 and divide it by 3 people and still have no money. Here I'm going to add 3 to both sides. I have 4x equals 3. I'm going to divide both sides by 4. And I'm going to have x equals 3/4. So my answer for number 1, my 2 answers are 0 and 3/4. and I'm done. For number 2, with the perfect squares, I'm missing that middle term, meaning it drops out. So that means I'm going to have the same thing in my binomials. I'm going to have an x and an x. I'm going to have a 3 and a 3, but one's going to be a plus and one's going to be a minus. I know I'm done with just my binomials because there was no equal to 0. I don't have to split and solve it. And this is where it ends if I don't have to split and solve it. Similarly with this perfect square one, I'm going to go to my binomials right away. I can break down the 49 into 7x and 7x. I can break down the 1 into 1 and 1. But now I don't want that middle term to drop out. I want to keep it. And I want these, I think there's actually a mistake in this one though. This needs to be a positive, so just go ahead and change that. I'll change it in on my key before it gets uploaded. That needs to be a positive one because what happens is I need this to be a minus and I need this to be a minus. So I need negative 7x here, negative 7x here to give you a total of negative 14x. But then when we check our first and our last, 7x times 7x gets us 49x squared. Negative 1 times negative 1 gets us a positive 1. If it didn't have that, it would actually not be factorable. So just make sure you change that. I'll make a note on mine as well. And because we were not solving it, we are done. All right, for this one, since a is equal to 1, we're looking at this number, which is 16. So we have 1 times 16, 2 times 8, 4 times 4. Okay, and since it's a positive 16, we are adding. So if we add, we get 17, 10, or 8. We want the 8, and we want a positive 8, so we want both of those 4's to be positive. So since we have a equals 1, we can go right to those binomials, which makes it x plus 4, x plus 4. Since it's equal to 0, we're splitting and solving. So from this point on, we want to take this and we want to say x plus 4 is equal to 0. X plus 4 is equal to 0. We basically just give the equal 0 to both of those binomials. We can subtract 4 from both sides to get x equals negative 4. Do the same over here. And both of these gives you x equals negative 4. This is actually what's called a double root when our answer happens at the same number. This actually, if you notice, was also a perfect square. And if you had seen that, you could have done it that way too, with the 1 and the 16, adding to the 8. And you see that because you use the 4 and the 4. All right, looking at number 5, we're looking at positive 8. So positive 8, our factors are 1 and 8, 2 and 4. It would turn to 4 and 2, but that's a duplicate. So we're adding. That gives us 9 and 6. We want the 6, but we want negative 6, so we want negative 2 and negative 4. Because it's a equals 1, we can go straight to the binomials. So we have x and x minus 2 minus 4. No equal to 0 here, so we can go straight to putting our box or our circle around it because we are done. All right, and then they save the best or the longest for last. With a being greater than 1, we have to do grouping. We have to take 3 times the negative 2 to get negative 6. And now we have 1 times 6, 2 times 3. And the minus or the negative means we're subtracting, which means we're either at 5 or 1. So since we want 1, we're using the 3 and the 2. And we want a positive 1, so we want positive 3 and negative 2. We're going to split this. So we want negative 2x, positive 3x. We're going to bring down the minus 2. We're going to bring down the 3x squared. We're going to put parentheses around the first 2. And the last 2. We're going to make our template, GCF binomial, GCF binomial. And then we're going to place our numbers. So our GCF of the first set of parentheses is x, and then we get 3x minus 2. Our GCF of the second is, well, we have a plus here, but we can place our second parenthesis. It should match our first, so 3x minus 2. What times 3x gets me 3x? A 1, right? So now we put our 3x minus 2 there because they match. We place our other 2 that we need to partner up. And this wasn't equal to 0, so we put that there. So now I know that 3x minus 2 is equal to 0, and I know that x plus 1 is equal to 0. So I subtract 1 from both sides, and I get x equals negative 1. Ooh, this one's going to be tight, space-wise. All right, I add 2 to both sides. I get 3x equals 2. I divide both sides by 3, and I get x equals 2/3. And I'm all done. All right, like I said, this week is a lot packed into a little. You know, you see not so many videos and you think like, oh, this isn't going to be so bad. But it is a lot of material, so don't panic until we meet. After we meet, if you need to meet with me one-on-one, we can do that. And we will see each other on Tuesday. We will talk then, and we'll touch base. Message me if you need to. Have a great week, and good luck on all of your stuff. I'll talk to you soon.